Hello, this is Mrs. Hickman, and today in this section we are going to be going over the mean value theorem. This is also a good AP Cal question. When you justify things, they want to see the mean value theorem. So, mean value theorem. So, if y equals f of x is continuous at a point on a closed interval a to b and differentiable at every point of a to b, then there is at least one point c in the open interval a to b at which the instantaneous rate of change equals the mean rate of change. The mean rate of change is another way of saying the average rate of change, which is the secant line. So we're going to be seeing where, so here's the secant line. So in this lesson, we're going to be determining what c value will they be parallel. Okay? So this is kind of a funny story. Rolle's theorem. So Rolle's, I forget his first name, but he actually did not like calculus, and he actually was trying to disprove this calculus theorem, except for the fact that he actually proved it, okay? So he actually made the most common proof of the mean value theorem. So what he said, so if f of a equals f of b equals 0, so which means they're crossing the x-axis there, then there is at least one c such that f prime of c equals 0, which makes sense. If you have, let's see, you have an a here and a b here, so one's crossing, let's do this one, one's crossing here, one's crossing here, they got to turn around sometime, so he's saying there's going to be a max or min there, and there is, there's a min there. Okay. So examples. So we're going to determine if the mean value theorem applies, and if it does, we're going to find the value of c. So to determine that, we need to find out what c is. Okay, so we're on an open interval. So we're going to be using this equation. So f prime of c equals f of b minus f of a over b minus a. So pretty much the first thing you do, where you see x just turn into a c. So f of c equals c to the 2/3. Okay? F prime of c is going to be 2/3 c to the negative 1/3. Okay? And it might be helpful to go ahead and put that in the bottom. So f prime of c equals 2 over 3c to the 1/3. Okay, so now we're going to set, so now we have f prime of c equals f of b minus f of a over b minus a. A and b are right here. A is 0, b is 1. Okay, so we got f prime of c is 2 over 3 to the 1/3. 3c to the 1/3. F of b, so we have f of 1 minus f of 0 over 1 minus 0. So that's going to be 2 over 3c to the 1/3 is 1 to the 2/3 minus 0 to the 2/3 over 1 minus 0 is 1. So then you have 2 over 3c to the 1/3. It might be helpful to go ahead and find f of b and f of a. It might give you some room. Equals 1 to the 2/3 is 1, 1 over 1 is 1. So now you're solving for c because you're looking for that x value where that is going to happen. Okay? So cross multiply there. So you're going to have 2/3 equals c to the 1/3. Okay? You cube both sides. And that c value you're looking for is going to be 8 over 27. So at that point, 8 over 27 is where the secant line in this and f prime c there is going to be parallel at that c value. Okay, and you can check that easily. Well, you can't check it easy in a calculator. You would need the tangent line. But, yeah, which we will get to. So that is the value of c to where it is parallel. Okay? All right. So the mean value theorem connects the average and the instantaneous rate of change. Okay, next problem. So we're defining some value of C on 0 to 4. Okay? So let's just make sure first it's differentiable. Here, so here the only place it wasn't differentiable was at 0. Okay? But it's close enough to 0 that we didn't have to worry about it. Okay? So that's what we did there. So here, so remember that the mean value theorem has to be differentiable at every point within the closed interval or the open interval. But this is the absolute value function. So if we were to graph this function, it's a transformation to the right 1 unit, it looks like this. And as you can remember, on this interval, we can't find a letter C because it's not differentiable there. So let's go over these non-differentiable things real quick here. So on the graph, it's not differentiable if there's a corner, okay, a cusp, a vertical tangent, okay, they kind of look like there, right there, and or a jump, which is going to be piecewise. Okay, so that's everywhere where it's not differentiable. So here, 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 and there. Okay. Back to this. Okay. All right, so next one. Write an equation for, so using this, write an equation for the secant line AB. Okay, so A is 1, B is 3. My blue's running out. I need another color. Okay, so I got one. All right, so this is A, that's B. So write an equation for the secant line. Okay, well, that's easy. So I need to find the slope. How do you find slope? Well, f prime of C, from what we learned, f prime of C is f of B minus f of A over B minus A. So we're going to write the, so that's how we're going to find our slope. Okay, so f prime of C is f of 3 minus f of 1 over 3 minus 1, which is going to be the square root of 3 minus 1 minus the square root of 1 minus 1 over 2. So you have square root of 2 minus 0 over 2, which is the square root of 2 over 2. But we're finding an equation, so that's our slope. You didn't see any of that, did you? Okay, f of 3, you're putting in 3 to the function square root of x minus 1. Okay, square root of 2. There you go. So you're writing an equation for the secant line. So there's your slope. And we have one of our points is going to be, let's use the one with the 0. So we have either point, so when we did this, we have 3 square root of 2. So AF of A is 3 square root of 2. Or we have 1, 0, which is the one I'm going to use. BF of B. Oops, I did these backwards, didn't I? I did these backwards. That's B, that's A. So to find the secant line, y equals m, which is square root of 2 over 2, which is f prime of C, times x minus 1 plus 0. So you get y equals square root of 2 over 2, x minus square root of 2 over 2. Okay, so that's the secant. So that's the equation of the secant line. So if I was drawing this graph, x minus 1 between these 2 points, I would have that. And I actually have this in the calculator ready to go. Okay, so let me show you that. Okay, so there's 1. So it's 1, 0. And then where it's going to cross is going to be 3 square root of 2 over 2. Okay, if I put trace here, 3 square root of 2 over 2. Okay. Oh, it's just square root of 2. Yeah, 3 square root of 2. Duh. There you go. See? Graph, trace, same thing. Okay, now we're on B. Write an equation for the tangent line to F in the interval 1 to 3 that is parallel to A to B. Okay? So, that's going to be F prime of C equals F of B minus F of A. So we have F of C. So F of C is, so you're just changing the X of C, is the square root of C minus 1. F prime of C, or F of C, is C minus 1 to the 1/2. F prime of C is going to be 1/2 C minus 1 to the negative 1/2. Or, okay, so F prime of C is going to be 1/2 times the square root of C minus 1. Keep the 1/2 there. So in the other one, we found out what F prime of C was, and it is square root of 2 over 2. Okay, cross multiply, so that 2 is going to cancel out, so you're going to have, let's see, so you're going to have square root of C minus 1 equals 1 over square root of 2. Square both sides. Okay, you get C minus 1 equals 1 over 2. Add 1, you get C equals 3/2. Okay, so that's the point. You're finding the equation. So you need to find a y value to where that happens, because you need to find what that point is. So that C, so remember, the tangent line is going to be the point on the line. Okay, so right here, if I can bring my graph up. Okay, so right here we found our C value to be 3/2. Oops. Okay, right here is where you're going to see that positive slope happen. Okay, but we need to find what the y value is. And to find that, you do F of 3/2, which is going to be 3/2 minus 1, which is 3/2 minus 2 over 2, which is the square root of 1/2, which is going to be square root of 2 over 2. Because you have 1 over square root of 2. Rationalize the denominator by multiplying by square root of 2 over 2 on both sides. Okay? Alright. So that's our, so M, our slope is square root of 2 over 2 from here, because a parallel line has the same slope. And our point is, our point C where this happens is 3/2 square root of 2 over 2. Okay, so that's going to be at y equals square root of 2 over 2, x minus 3/2 plus square root of 2 over 2. Okay, which is going to be square root of 2 over 2, x minus 3 square root of 2 over 4, plus, I'm going to go ahead and make that into a fraction, 2 square root of 2 over 4, Okay, so your tangent line is square root of 2 over 2 x minus square root of 2 over 4. Okay, I'm going to unlock that. Okay, so that's that line that you are seeing being drawn right now. Okay. And you see a nice parallel line. So to review all this really fast, to wrap it up, the first section was to find the equation of the secant line. Okay? So they gave you, so to find the equation of the secant line, you don't need a function. You just need 2 points, f of b minus f of a, b minus a. Okay? And of course, f prime of c is the slope, because that's what a derivative is, a slope. So we evaluated that in here, and we end up getting square root 2 over 2. So one of the equation of the secant lines, so there's my slope, and I just chose one of these 2 points. Either one would have worked. So this was a f of a, that was b f of b. Okay, there is my slope. I choose that point, and I got that. The letter B was asking for the tangent line. So that's, you're looking for the instantaneous. So that's why I had to make the original function, the square root of x minus 1, into here. Because you're looking for the point C where it's going to be parallel to this. So that's why I had to set this, the derivative of this function, equal to the slope that I got up here. And then I did algebra to find C. Okay? But I still needed to find a y value so I could put in my tangent line. I can't use this or that, okay? Those points aren't valid for instantaneous point. This is over an interval. My x value is here, so I needed to find my y value. So to find my y value, I put 3 halves into this equation. Algebra, I got square root 2 over 2. So my point where the tangent line is parallel to the secant line was at 3 halves square root 2 over 2. My slope was square root 2 over 2 here. Okay, it's parallel. Parallel lines have the same slope. And then I did m times x minus x1 plus y1, and you got that. Okay, so that is the mean value theorem, and that is all for right now. Have a good night.